Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the January 2024 Mechanics M1. This is the International A-Level Edexcel paper. And here we have a beam, AB, of mass 30 kilograms and length 3 meters, as you can see. The beam rests on supports at C and D. AC and also BD are 0.4 meters, as we can see in the diagram. A person of mass 55 kilograms stands on the beam between C and D. The person is modeled as a particle at the point P. So he's standing at the point P, where Cp is equal to x, which is somewhere between 0 and 2.2 meters. The beam is modeled as a uniform rod resting in equilibrium in a horizontal position. Using the model, show that the magnitude of the reaction at C is 686 minus 245 newtons. So I've got a little diagram here so that I don't have to keep scrolling up and down when I'm making my equations. So basically, the important thing that we can see from this, for us to be able to start here, is that we have one of the things is a uniform rod. So the beam is a uniform, it's a rod, it doesn't bend, it doesn't buckle. It's uniform, meaning its weight can be taken to act through its geometric center. So it's 3 meters long. So we take the weight to the center of mass, the place where the weight acts from, exactly halfway along its length. Okay, so let's say that's 1.5 meters in from the end. Okay, so that's where we take its weight to be acting. Okay, exactly. Let me just draw it here. That length is basically 1.5 meters. Sorry about that. 1.5 meters in from the end is where the weight acts. The weight of the beam is 30 G newtons. 30 G newtons. Okay, that is the weight. That's one thing. Resting in equilibrium in a horizontal position. Okay, so we have the other forces acting on it is the fact there's a man standing at the beam at the point P. So you got a man standing at this point here. Okay, and that man has a mass of 55 kilograms. So his weight is going to be 55 G newtons. And his distance away from the support C is x meters. And the other forces acting, of course, will be the reaction on the support C and the reaction, okay, on the beam from the support D. These reaction forces here, okay, are reaction forces on the beam from the support. Okay, so this is a reaction force on the beam from the support C and on the beam from the support D. Okay, so some people ask about this situation like this. They say, okay, they'll say, isn't there reaction force on the beam as well, on the supports as well? Well, yes, there are, of course. Okay, there is a reaction on the support itself as well. But because we are considering only the forces acting on the beam, we're not thinking about those reaction forces. We're looking at the forces acting on the beam. Okay, that's what we're thinking about. The forces acting on the beam itself. Okay, so that's what we consider here. Okay, so we consider the weight of the beam itself. We consider the weight of the man on the beam. We consider the reaction force of the beam, of the supports on the beam. That's what we're considering here. All right, so now, show that the magnitude of the reaction at C is 686 minus 245 newtons. So if we want to find the reaction force at C, okay, here we have another unknown force, the reaction force at D. Both of these are unknown forces. Okay, so for us to find the reaction force at C, what we should do is take moments about D. Okay, if we take moments about D, that will make life very easy for us. Okay, we could, if you wanted to, take moments about some other point. In fact, then you'll have two equations, one in reaction, one will be with RC in it, the other one will be with RD in it. For example, if I took moments about A, I'll have two equations. Okay, I have one equation, sorry, with two unknowns, RC and RD. And then I could take moments about some other place, and I'll have another equation, or I could use the fact that the total weight upwards, sorry, the total forces upwards and the total forces downwards will be equal to each other. So I can use simultaneous equations, but the easiest by far way to deal with it is to eliminate one of those forces immediately by taking moments about the force that we don't need to know. So I don't need to know the reaction at D. Let me take the moments about D. The moment of a force is equal to the magnitude of the force times its perpendicular distance from the place where you take your moments about. So if I take moments about D, RD times 0, RD is gone. There's no turning effect of this force about D. So we don't have to worry about the reaction force at D, and I'll have an equation with one unknown. Okay, so that's why it makes sense to take moments about the point D. Okay, we take moments about the point D, we have to think about the distances of these other forces from the point D. Okay, so let's first think about the clockwise force. Now, the clockwise force would be the force of the force of this other reaction force about D. That would, if I held this still at this point here, all right, and I pulled up according to this force, and I put my finger down over here, then this would go clockwise. Okay, so you've got this distance here, okay, is what I need. Now I know that the whole length of the whole beam is 3 meters. And I know that this part is 0.4 and this part is also 0.4. So the distance between the two pivots is going to be 3 meters minus 0.8 meters, because you got 3, the whole thing, minus 0.4 minus 0.4, that's minus 0.8. That's going to be 2.2 meters. Okay, so the clockwise moments, okay, about D is going to be 2.2 times RC. Okay, and that is what I have to find, RC in the end. Now, the other two forces, this weight of the man and the beam, they would have the effect of being anti-clockwise about D. Okay, they will kind of have this kind of effect. So the clockwise moments, as it's in equilibrium, will equal the anti-clockwise moments. So now I need to know these distances. So I need to know the distance between these 2 points here. Now I know that the whole distance here is 1.5 meters. Okay, because why? The distance between here and all the way to there is 1.5 meters, because this is halfway along, that's 3 meters. So this distance that we're looking for is going to be 3 meters, sorry, 1.5 meters minus 0.4 meters, which is going to be 1.1 meters. So the force 30G, so you have 30G times 1.1, that's one of the forces going to be anti-clockwise. And the other one that's going to be anti-clockwise is this weight of the man. Now we need to find the distance between this support D and P. Okay, now I know that the distance between the two supports, as we said, was 2.2. The distance between the two supports is 2.2, as we worked out earlier. So the distance between here and here is x. So this distance here is going to be 2.2 minus x. Because remember, this is 2.2. So this distance is 2.2 minus x. So we're going to have the weight of the man, which is 55g times 2.2 minus x. So we have to get our distances really well thought of in this type of question. Now, hopefully, when we rearrange this to find RC, we should get exactly this equation. Okay. Now remember, our G is 9.8 in our syllabus. So we have 30 times 9.8 times 1.1 plus 55 times 9.8 times 2.2 minus x. Okay, that's in brackets there. Okay, and this is all going to be over 2.2. That's all going to be over 2.2. So let's see what we get. So we have RC equals, let's take the calculator. So we have 30 times 9.8 times 1.1. Make sure we type everything in properly. That gives us, in decimals, 323.4. 323.4 plus, I'm going to have 55 times 9.8 times 2.2. So 55 times 9.8, that gives us 539, which will be, so you're going to have here that times minus x, so it can be minus 539x, but also that is going to multiply by 2.2 as well. So we're going to have, just to make sure, 539 times 2.2. That gives us 1185.8, 1185.8. Okay, and all of this is going to be over 2.2. So we can say RC equals, so add these together. So that plus 323.4, that gives us 1509.2, 1509.2 minus 539x over 2.2. So let's hope now when I divide each of these by 2.2, I get exactly what we asked for. So this divided by 2.2 gives us 686. That looks right to me now. 686 minus, and we have 539 divided by 2.2, which gives us 245x. And is that what we had to show? Yes, 686 minus 245x newtons. So we can say RC is equal to 686 minus 245x newtons. Okay, so that's good. That worked out fine. And there's the answer to part A. Now we're going to move on to part B. So just remember, let's remember that 686 minus 245x. So we have, okay, I've already got it there. That's fine. So it says, now they've given us some more information. They've told us that the magnitude of the reaction at C is 4 times the magnitude of the reaction at D. Using the model, find the value of X. Okay, so we know the reaction at C now is 4 times the reaction at D. So the reaction at C, okay, so the reaction force at C is equal to 4 times the reaction at D. Okay. So that means if this is R, this will be 4 times R. The reaction at C is 4 times that at D. So D is R, this is 4 times R. Okay. So we also know that the total weight was, it had for the man and for the actual beam itself, the total weight acting down for both of them, one of them was 55, this is 55G, and this was 30G, right? So what I can say here is these R's are now related to each other. They're not unlike terms. There's one unknown here, okay? Because for that because this R is now in terms of that R. So we can say that if we resolve the forces vertically, that we can say that 4R plus R, which is 5R, is equal to 55 plus 30, that's 85G. So we can say R is equal to 85 over 5, which is 117G newtons. So I know now the value of R, okay? And therefore I can work out what X is, because I know that the reaction at C, this is the reaction at C, is given by this much. So I know that the reaction force at C is equal to 4 times 17G, which is going to be 40 plus 28, that's 68G newtons. And I also know the reaction force at C is also equal to 686 minus 245x Newton. So these are equal to each other. So I can now make an equation. I can say 686 minus 245x must be the same as 68g. So I can now say 686 minus 68g is equal to 245x. So therefore x is going to be 686 minus 68g divided by 245, and I can get my answer. Remember, g is 9.8, so I'll have 686 minus 68 times 9.8, sorry, divided by 245. That gives me 0.08. So x is 0.08 meters. Okay, so that's the value of x, and it looks a bit small, but remember it said x is between 0 and 2.2, so it's kind of, that's fine. I think we did everything correctly, so that's fine. The distance between the pivot and where the man is standing is 0.08 meters, and that's the answer to part B. Then it says the person steps off the beam and places a package of mass M at A. So he's come off the beam now, and so there's no 55 kilograms, but he's put a package which is of mass M, so its weight will be mg at A. It's still the same uniform beam, so it still has the weight, which was 30. Let's make sure in case I make a mistake. It was 30 g newtons, yes. Okay, so I have 30 g newtons, the weight. All right, and it says here, the package is modeled as a particle at the point A. The beam is now on the point of tilting about C. Very typical type of question. On the point of tilting about C. All right, so basically what it means is it's about to do this. Okay, just imagine you have your beam. Let me get a shape here. So you have your beam. What's about to happen is it's about to do this, but over C. Okay, this can't do it from the center. So it's about to, let me just do this. 1 second. Make this a bit smaller. Okay, so this is about to happen. Okay, just imagine that, we're talking about this beam, and it's like this goes all the way up to there. What's about to happen is this. It's about to tilt with the rest of it attached to it as well. Okay, it's about to tilt about C. That's about to happen. Okay, so when it's about to tilt, that means that the force of this beam on D is now, it's going to become 0 when it's just about to tilt. It's not tilted yet. It's still in equilibrium. The moments are balanced out, clockwise, anti-clockwise, upward and downward forces are still the same, are equal to each other. However, it's just about to lift off. It's on the point of tilting about C. So there will be a reaction force on C only. On D, there will be no reaction force. Okay, on D, there will be no reaction force because it's just about to tilt on C. Okay, let me just try and illustrate that better. Okay, so what we can see here is, imagine this is the beam, okay, resting on C. What's going to happen is something like this. Okay, it's going to tilt, and above D, there's going to be, okay, just imagine this is the beam. Okay, I'm just trying to illustrate it so it's a bit clearer. So you see, if it's not about to tilt, it's going to stay like this, right? And there'll be reaction force on D and C. Now, when mg is added to it, when you put a weight over here, it's like, it's about to start tilting up. Okay, it's gonna fall down. If this weight was any bigger, what would happen is the whole thing will tilt up like this. Okay, so that's what's going to happen. And forget that extra part. I've drawn an extra length there. I should have actually done this. Actually, let me just do this. No, I shouldn't have done that. No problem. Leave it like that for now. Okay. So basically, what's going to happen is when it's just about to tilt, when it's on the point of tilting about C, the reaction force at D is going to be equal to 0. Okay, so the reaction force at C will be only reaction force will be on C. The whole weight, you could say, is going to be on C. And here it's just about to lift off. So the reaction force on D is going to equal to 0. And that's the key of answering these questions when it says on the point of tilting. So this is going to be, RD is going to be 0, and RC is going to be the total weight of these two. Now, we don't know the weight of these two because we don't know the mass of this object now. The man is gone. There's no man left anymore, right? He just left a weight here, and he went off, and this beam is just about to tilt. Okay, so the reaction force at D is 0. But that's the key to answering this question now. Okay, because if we take moments about C, we don't know what the reaction force at C is because there's two unknowns. This is unknown and this is unknown. However, if I take moments about C, then I don't have to worry about what that force is. Then I can say, okay, the clockwise moments and the anti-clockwise moments are the same, and there's no moment given by this force because this force is 0 now. There's no reaction force at D because it's just about to lift off from D. It's just about to, on the point of tilting about C, meaning this is just like there's no force between these two. It's just about to lift off from it. So the only forces acting now are these two that we have to worry about. Okay, we don't have to worry about the reaction force at C because we're taking moments about C. So the clockwise moments will be given by 30g times this distance here. And we know that distance there from before. We know that distance here. Okay, that is, remember, that's 0.4 and that's 1.5. So this is going to be 1.1 meters because 1.5, remember, was halfway along. Okay, so it's 1.5 minus 0.4, that's 1.1. So the 30g times 1.1 plus, sorry, equals, not plus, equals, because that's the only clockwise force, and it equals the anti-clockwise force, which is mg, times 0.4. So the only thing we don't know here is m. So we have 30g times 1.1 over 0.4g. The g's will cancel out. So we can say that m is equal to 30 times 1.1. So we have 30 times 1.1 divided by 0.4. Divided by 0.4. And that gives us 82.5 kilograms. 82.5 kilograms is the mass of the object placed on the end of the beam, okay, which was A. All right, so that's the answer to this question. I hope that was clear. Other questions from this particular paper will be found in the playlist that will be appearing over here. Its link will be over here. Other questions from the topic of moments from M1 over here. You'll have a playlist that will be linked here. You can subscribe to my channel by clicking on this link, and you can watch a video that will appear, and this link will appear over here, which will tell you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.